The announcement last night that Brian Schmidt has been named as the joint winner of the 2011 Nobel Prize in Physics is a great day, obviously for Brian, but also for the ANU, for the City of Canberra, and indeed for Australian science. We at ANU are enormously proud of Brian's achievements, as is, I think, the whole nation. Brian's work on the expansion of the universe has fundamentally changed astronomy today. His work has helped unveil a universe that was to a large extent unknown to science. So on behalf of ANU, I'd like to offer my congratulations to Brian for what is a magnificent achievement based on many years of outstanding science. So ladies and gentlemen, without further ado, I'm very pleased to be able to introduce Professor Brian Schmidt.
Thank you, everyone. It's a great honor to get this award, obviously. And for me, I think we think of Nobel Prizes as being a personal achievement, but really it's a celebration, I think, of astronomy and the science that's been going on for 100 years. And I think it's really symbolizes what we can do here in Australia. I came here, immigrated from the United States in 1994, 27 years old, and was provided at the ANU the support to undertake this work, to lead an international team, and that's something I think that's really uniquely Australian, to be able to start so young on something so big. And so for me and my colleagues, there were 20 people in the team that helped discover the accelerating universe in 1998. It really is a great day, but I hope it's seen as that celebration for everyone, both in Australia and in astronomy.
What do you think this award means for the future of Australian science? And do you think the government is investing enough in innovation and generating or helping the new generation of scientists?
So I think that this award should show Australia that we can really do great things here. Now, you can always fund science more, but you can also fund science better. And so what I hope we look at is how to use the money that we use in science and innovation to really hone in on where we can do great things internationally. And I think we're not going to decide that today, but I think it will hopefully open the discussions of what allowed me to do what I did here, and we hopefully can translate that so more people can do that.
Professor, the knowledge seems rather abstract. Can you bring it down to a sort of a Earth?
So what we discovered by looking back in time at very distant exploding stars, which have the virtue of being very bright, so we can see them 5 billion years into the universe's past, we were able to track how the universe expands over time. Now, we expected the universe to slow down due to all the gravity that's in the universe, where our gravity of galaxies and stars, should slow the universe down. What we found was the opposite. The universe was speeding up. It was being pushed, which means that gravity is working differently than we expected. The solution comes from Albert Einstein, who said if the universe is full of energy, space itself has energy, that will cause gravity to push rather than pull. So it would seem that by discovering an accelerating universe, our team actually discovered 75% of the universe is this new magical stuff we call dark energy.
What does this mean for the future of the universe, though? I mean, if it's expanding at a more rapid rate, does that mean that, the universe is going to collapse on itself sooner rather than later?
So it actually means the opposite. The universe, because it's speeding up, is getting away from itself faster and faster over time. Everything is moving away faster and faster. So right now, I look out into space and I see billions of galaxies. In the future, people will look out and they will see an empty universe. All the galaxies we see now will be so far away their light can no longer reach us. And so the future for the universe appears to be very bleak. The universe that's empty, it's cold, and our galaxy of stars, which will not, it turns out it's not expanding away from us, will slowly fade away and die, and we're left with a bunch of stellar embers and a dark universe.
But how far away is that? I'm sure it's billions of years away.
It is hundreds of billions of years in the future, but that's not too long by astronomical standards.
Professor, I'm actually feeling a bit lonely at this point, but can you tell us how it might be applied, the knowledge? Or is the knowledge just for itself?
Yeah. So knowledge is a very funny thing. In the 1920s, people discovered quantum mechanics, that atoms can sort of come in and out of existence. And that eventually led to the idea of computers, the whole silicon-based revolution. And that was from something that was fundamental that people said in 1920, what use is this? People here in Australia in the 1980s and 90s, studying evaporating black holes, or trying to discover them, invented Wi-Fi, 802.11, worth billions of dollars around the world. So knowledge is a funny thing. I do not know whether or not the accelerating universe is going to give us a better toaster. But I do know it will help us understand the universe, and what that eventually evolves into is to be determined. That's the way science works.
Where's your research heading?
So the observatory burned down in 2003, and after that we took the 5 telescopes that burned to the ground and we consolidated them into a new telescope called SkyMapper. And so SkyMapper is a telescope which is just coming online now, which is going to take a picture of the entire southern sky, 10 million times fainter than you can see with your human eye, 36 times over the next 5 years. And for that we're going to be able to use it to study everything from the solar system to the most distant objects in the universe, and that will be used by astronomers across Australia.
You mentioned
so the knowledge is just good for its own sake.
Again, knowledge is funny stuff. You have a pyramid of base knowledge, and then things derive from them. And so everything we have here today is based on fundamental knowledge that percolates up the chain. And so yes, I'm on that fundamental thing. And if I can invent something like Wi-Fi, I will, but I can't guarantee I will.
It's a lot more than a belief system, isn't it?
It's a process of learning about the world we live in, and so it is the way that modern society has got to where it is. This idea of scientific inquiry has taken us from the Dark Ages to where we are now, for better or worse.
You mentioned that the government can always do better on funding and target, certain areas. What areas though? I mean, does CSIRO need more funding? Does the ANU need more funding?
Well, I think what we really need to look at is always a little bit of money would be good. For example, the Australian Research Council right now, people like myself who apply to this have less than a 20% chance of getting their money. So that's very low by international standards. But that being said, we can also use the money that we spend wisely. So one of the things I really want to emphasize is stability of programs, really important, so that 5 years from now I have some idea what I can expect to do. That's much better than having a new brilliant idea every 3 years, which, although may be a good idea, changes the groundwork so that we can't plan.
So are there certain sectors of Australian science that are better placed for funding?
Yeah, so right now, I mean, there are parts of Australian science, like astronomy, that do very, very well internationally. And we're not the only area that does that. There are other areas that don't perform as well. But you sort of have to let the whole process evolve, I think, over time. Because what is great now, in 20 years, may be pretty mediocre. And so I would hate to be rigid on things. And the whole idea of peer review and things, I think, works pretty well. But I really do think just a stability of funding, and so that we know where we're heading at any given time, has been certainly important to me at the ANU, which has its block grant, but I think would be valuable for the rest of Australia as well.
Could you reflect on the attack on the scientific community in Australia during the carbon debate?
Well, I think the Academy of Science has looked into the carbon debate quite carefully, has produced a nice little booklet that sort of describes the nuances of carbon. And, science is never absolute. That's the problem. You have different levels of assurity. And so I have won the Nobel Prize with my team today for discovering the accelerating universe. We're pretty certain that's correct, but you're never absolutely certain. The carbon debate centered around the science. Is the science right? Well, there are uncertainties in the science, but I think the evidence is quite strong that change is happening. Now, change does not just mean it gets warmer every year. Change is change. Things can change in weird ways, and it's very hard to measure. And I think the science behind climate change predicts there should be a little change right now, but the future, the prediction is it'll be much more. And I think we're going to do that experiment, so 20 years from now, we'll see exactly how good those models are.
Has the attack sort of diminished the standing of science in the community, do you think?
I think that it has maybe in the short term diminished in some people's minds the standing of science, but to my mind it's part of the scientific debate. We need to make sure we don't mix policy and science directly. The science is science, policy is policy, and I would really like the scientists to continue to debate what's right and what's wrong about everything, accelerating universe, climate, and I'd really like the policy people to debate how to deal with what is coming in from the scientists, rather than, debating in ill-formed scientific debate.
It's pretty mixed up, isn't it?
It is a little messy, but that's the way life is.
So do you think that science has to have a greater informing role for a number of areas of public policy?
I think that science should inform public policy. Public policy then needs to take that as an input. It doesn't mean it's the only input, but it's part of it. But I think it's really important to keep them distinct entities, so we make the best call of what we think is happening and the uncertainties on that, because you need to understand what you know and what you don't know, and that's an important part. And then the policymakers need to reflect on that and make policy decisions which benefit the nation.
What are some of the areas that you think it could inform policy better on?
Well, in addition to climate change, I think we have all sorts of environmental issues which really need scientific input. But then there's, ideas of how to deal with funding of medical research. I think that really most of the issues that have a technology side to them really can be informed or improved with scientific advice at some level. So really, there's very little when you think about it that doesn't ultimately have some component of science or economics, which is obviously the other side. But economists are a social science, but my wife is a social scientist, economist, so I get to hear a lot about that side too. But I think informed debate on that side is an important side of policy.
Is this what it meant for your life personally?
That is going to be determined. I like my life as it is, so I'm hoping it doesn't change too much. But I do hope it'll allow us to advance in science in Australia and to serve as, I think, an inspiration for budding young scientists to say, geez, maybe I could do that. Because when I started out, I didn't even dream about winning Nobel Prizes. It wasn't what I was doing. Never expected I would ever win one. So it can happen to anyone.
What are you going to spend the prize money on?
So my plan will be to put it to some sort of public good, and I'm not sure yet. I'm going to discuss with the other 20 members of my team and figure out what they think should be done.
How and when did you find out? The ANU and Canberra?
Well, the ANU has been a great place for me to do my work. It's especially Mount Stromlo is an absolute world-class institution. I came here from Harvard, which is a well-known institution, and I really didn't take a step down. So the environment here is great. When I came here in 1994, 27 years old, I was able to go out and do something absolutely world-class, and I hope we can continue that. The ANU is a different institution than it was in 1995. We've lost some of the things that differentiate us from the other universities in the country, and I think that does concern me. I think the ability to go out and have money that you don't have to spend 2 years applying for strategic funds are a really important component to research in this country, and I guess I'm hoping that we can make sure that that continues.
You're also making sure that you teach a class later on today?
That's right. So one of the things that I love to do is to teach, to keep connected with people who used to not be much younger than me, but are much younger than me now. And so I teach third-year cosmology at the ANU at noon today.
How and when did you find out about Eugene?
So last night at 8:30, I got a call from a Swedish accented woman, and my first thought was that, geez, my graduate students have done a pretty good job on this accent. And she wanted to confirm that I was indeed Brian Schmidt and told me I had a very important call. And then the members of the panel went out and read the citation to me and congratulated me and then said, we're having a press conference in 10 minutes. Would you like to be live on that? And so that's where we started.
Can I just ask if this achievement, how much of this achievement you can attribute to the way we do science here and the resourcing and facilities that are available to people like yourself? And that's unique here.
Yeah, so it's a really good environment here in Australia to do astronomy. We have first-rate facilities and we have a critical mass of people who are really at the high end. And so that was, essential for me to get my project up and running and to complete it. And so, having both a quality of infrastructure and quality of people are just essential. So in astronomy we have that. We have it in other fields in Australia. And I think the other thing was having, quite frankly, an incredibly supportive team that was dispersed around the world, who were almost all older than me. The only person younger than me on the team was Adam Riess, who was my co-winner. And so we were the two young people on the team, and the old people gave us the ability to go out and run with this project.